Hello everyone. In this session, we will see the IUPAC nomenclature for the coordination complexes. There are several rules of this IUPAC nomenclature to name the coordination complexes. Okay, so these are related to the naming of the metal center as well as the naming of the counter ions, as well as the order of listing the ligands and the metals, their prefixes, and so on. Okay, so we will discuss one by one. The first rule is related to the order of naming the ions. Actually, those are the counter ions. Okay, so we have the positive counter ion and the negative counter ion. So in this, the positive counter ions always written before the coordination sphere. Okay, that is before the coordination complex ion. And if there is a counter ion which is negative one, it should be written at the last, that is after the coordination sphere. Okay, for example, this one, this is the complex which has the 3 chlorine as the counter ion. So the name of that counter ion, that is chloride, it should be written at the last. Okay, so the name of the coordination sphere, that is coordination complex ion, and then there is a name of the negative counter ion. Okay, on the other side, if you have the positive counter ion, it name should be written before the coordination complex ion. Okay, and it should be written as it is. If it is potassium, write potassium. Okay, if it is NH4 plus, that is ammonium, write ammonium as it is. Okay, no prefixes for the counter ion should be allowed. Okay, it means that if it is 3 number of potassium, there is no what we say, that there is no use of writing tri potassium. It is only potassium. Okay, while similarly for the 3 chlorine, there is no need to write the 3 chlorides or the trichloro. It is simply chloride. It is only for the counter ions we are dealing. Okay, so this is the first rule to name the positive and negative counter ion. Okay, so positive counter ions always written before the coordination sphere, and negative counter ion always written after the coordination sphere without any prefixes. Okay, the next rule is related to order of listing the central metal and the ligand. Okay, so within the coordination sphere, that is coordination complex ion, first write the name of the ligand followed by the metal one. Okay, and specifically for the ligands, having the different ligands, if it is there, and then write the name of the ligand alphabetically. Okay, for example, we have the two different types of the ligand, chlorine and bromine, that is chloro bromo. Write the name of the bromine first, then chlorine, and then metal. Okay, so within coordination complex ion, the first always name should be of the ligand and then metal. Within ligand, write the name of the ligands alphabetically if there are a number of ligands. Okay, this is about the second rule. Okay, then next one, regarding to ending of the ligands. So as we already know that in the ligands, we have the two different types of the ligand. It is negative one and it is neutral one. Okay, within negative one also, there are some ligands which are not commonly utilized, and on the other side we have the negative ligands which are commonly utilized. Okay, so for the negative ligands which are not commonly utilized, those are shown herein. They have the specific ending. Okay, for example, whatever the ending IDE or ITE or ATE. Okay, for such ligands, for such negative ligands, the ending IDE or ITE or ATE should be replaced. It means that the E at the last should be replaced by O only. Okay, so for the negative ligands end with the either IDE, ITE or ATE, the last letter E is replaced by O. Okay, for example, NH2 minus, it is amide group. Okay, it is common name, that is amide, but in concern with the name in the complex, it is amido. Okay, for nitrite it is nitrate. For sulfate it is for sulfide it is sulfito. For acetate it is acetate. Okay, and so on. We have, so there is thiocyanate also. We have the nitride also. So name of the nitride in the complex, it is nitrido. Okay, for imide it is imide, and so on. For oxalate it is oxalate. Okay, so these are the some negative ligands and their ending, how the ending should be mentioned in the IUPAC nomenclature during the naming. Okay, and on the other side, there are some common negative ligands, for example, halides, cyanides, or hydroxides. Okay, so in such cases, whatever the ending IDE mostly we have, that has to be replaced by O only. Okay, so if bromine, that is Br minus ligand, having the common name bromide, the name in the complex should be bromo. For chloride, it is chloro. For cyanide, it is cyano. For hydroxide, it is hydroxo, and so on. Okay, so this is about the negative ligands which are common in one. Okay, and their ending. And the next one, the neutral ligands actually. So neutral ligands, they are named as it is, as a molecule. Okay, for example, PF3, phosphorus trifluoride, it is the ligand and it is neutral one. So it name should be mentioned as it is, that is phosphorus trifluoride. Okay, or we have the ethylene diamide. Write the name as it is, ethylene diamide, during the naming. Okay, but of course, there are few exceptions. So this is about the exceptional examples of the neutral ligands. For ammonia, the name in the complex should be amine. For carbon monoxide, it is carbonyl. For nitric oxide, it is nitrosyl. For water, it is aquo or aqua. Okay. So this is the rule to name the endings for the negative ligands as well as the neutral ligands. Okay. Yeah, the next one is related to the numerical prefixes utilized for the ligands. Again, we have the two different ligands, monodentate one and we have the polydentate ligand. The polydentate ligand means the ligands already having the prefixes like tri, di, and so on. Okay, so first see the prefixes utilized for the simple ligand, that is monodentate ligands actually. So if you have the two number of ligand, it is di. For three, it is tri. For four, it is tetra, and so on. Okay. So we have the di, tri, tetra, penta, hexa, hepta, octa, nono, and deca. Okay. And for the single ligand, there is no need of prefixes. For example, we have the six number of ligands with one chloro and five bromo. So five, that is pentabromo, is okay. But regarding to chloro, monochloro is not required. So it is simply chloro one. Okay. So this is about the prefixes for the simple monodentate ligand. But on the other side, the polydentate ligands, those are the chelating ligands, we can say that they already have the prefixes like ditri. And for such ligands, the other prefixes such as bis, tris, tetracis should be utilized. Okay. So if you have the two number of such ligands, then it is bis. For three, it is tris. For four, is tetracis, and so on. Okay. The example we can see. Okay. We have the PF3, that is phosphorus trifluoride. Already it has the prefix tri within the name. Okay. So if it is two number of these PF3, then bis phosphorus trifluoride. Okay, if it is three number of PF3, then it is tris phosphorus trifluoride. Okay, if in concept with the oxalate also, it is polydentate, kind of polydentate ligand. So we have the three number of oxalate, then it is tris oxalate. Why oxalate already we seen in the naming of that negative ligand of the ligand. Okay, in connection with the ethylene diamide, tris ethylene diamine. Okay, so this is the way to write the prefixes or to use the prefixes for monodentate ligand and for the chelating ligands or the polydentate ligands. Okay, the next and the last one rule is related to the naming of the central metal center. Okay, so regarding the coordination sphere, we have the two types of the coordination sphere. Okay, that is complex ion. So either it is negative complex ion or it is positive complex ion or the neutral one. Okay, so regarding to negative complex ion, the ending of the metal should be with ATE. Okay, ATE. If it is Fe, it is ferrite. Okay, if it is copper, it is cuprate. Okay, and on the other side, if it is positive complex or the neutral one, there is no specific ending is required. Okay, for example, consider this. I think it is presumed. Okay, so consider this coordination complex. It has the counter ion potassium. Okay, it has the central metal Fe and it has the 6 number of cyanide, that is ligands, 6 number of ligands. So potassium has the +4 charge. It means that on the coordination pair it is 4 negative. Okay, 4 minus. So it is negative complex ion. Okay, see the charge on the coordination. It is negative one. If it is negative, there is ending of At. Okay, if it is Fe, then it is ending at ferret. Okay, and on the basis of previous rules, name of this coordination complex, we can say that write the name of the potassium as it is, that is potassium. Then we have the 6 number of cyanide, that is hexacyano. Hexacyano is there, and we have the Fe ferret because we are dealing with the negative complex ion. And at the last, after the name of the metal, central metal, write the oxidation state of that metal in Roman numericals, okay, within the bracket. Another example, take the example of the positive complex ion. Okay, so we have the central metal copper, we have the 4 number of ammonia is there, and the charge present on this coordination pair is positive one. It means that it is positive complex ion, and there is no specific ending. Okay, try to name of this complex as per the IUPAC nomenclature rules. So first write the name of the ligand. Those are 4. It means that tetra. So tetraamine copper as it is, because it is positive one, no specific ending is required. So tetraamine copper, write the oxidation state of the copper, which is 2 plus 2 within the bracket as it is. Okay, and another rule or some important aspect I can say that if there is counter ion, whether it is positive or negative one, don't write ion at the last. Okay, and if the complex is without the counter ion, always write ion at the last. Okay, a simple one. Okay, so coordination state of the metal represented by the Roman numericals enclosed in the bracket is the last IUPAC nomenclature rule we have to deal. Okay, so on the basis of these 4 major IUPAC nomenclature rule, we can name any kind of complex coordination complex. Okay, so for example, take the example of this one, third one. We have the central metal nickel. We have the 4 number of phosphorus difluoride, which is polydentate ligand one. Okay, so first thing we have to write the name of the ligand. Which one is the ligand? Phosphorus difluoride, which is polydentate one. So prefix is 4 means tetrakase. Okay, so tetrakase within bracket we have to write phosphorus trifluoride. After the bracket, write the name of the nickel, and it is neutral one, so there is no specific ending is required. Okay, so it is nickel only with 0 oxidation state. Right. On the other side, take the example of this one. We have the central metal chromium. We have the oxalato is there. 3 number of oxalate ions is there, and the complex is negative one. Okay, so there should be ending with ATE for the chromium, that is chromate, right? So first thing, write the name of the oxalate, that is trace oxalato chromium. I think it is printing mistake. Okay, there should be the chromate, right? Chromate 3 ion, because there is no counter ion. Okay, in connection with the fifth one, we have the central metal cobalt. Then we have the ethylene diamine as a ligand. Then charge present on the coordination pair is +3, so there is no specific ending required. Okay, so tris ethylene diamine cobalt +3 ion, +3 ion. Okay, due to no counter ion, we have to write ion as it is. Okay, so with this we will stop this lecture. So we have discussed the IUPAC nomenclature and the rules involved in the IUPAC nomenclature. Okay, thank you.